Okay. So this was the homework. There was all 4 problems on the textbook. There is also Delta Math that is required and due tomorrow morning, 7 a.m. And by Sunday, you need to finish the AP classroom thing. I haven't looked lately, but there were 8 of you that did it by Monday. Down on Monday when it was assigned Monday morning. Um, Tomorrow's a chapter 10 test. There are 3 concepts. Well, 3 units within one chapter. Can you do parametrics? Parametrics we did in September. They were easy doing the first derivative. Now they're like, and there is this extra wrinkle for doing the second derivative that you need to divide by that dx dt again, and how to find the length of a parametric, dx dt squared plus dy dt squared integrated. You get to use a calculator tomorrow, and I need to at least see, if you're calculating length, I need to see that. Don't just say L equals 5. How did I get that? I found out from nowhere. I need to see what each of these things stands for. If you calculated dx dt and calculated dy dt, you need to have it written down. So I need to see those things. Vectors and parametrics, very, very similar. Exception is the second derivative is super easy. The x position is just x. Well, how is x changing? What's its change in x? Do the derivative of that function, leave it where the x is. Derivative of the y position over time, then double derivative of that. Finding magnitude. Speed is just one portion of a velocity vector. So how do we take direction off of it? Well, we just find magnitude of that vector. It looks a lot like the length of a parametric curve. And a lot of you that actually did the textbook stuff, it was asking for direction vectors. That's a unit vector. And I don't have a lot of applications for that in this class. I don't care about them, don't worry about it. It will be important next year. I will not ask about it tomorrow. So those are the old things of being able to do a double derivative from a parametric and a length of a curve in parametric, and vector stuff, be able to do the first and second derivative. We also did things in class that, what is the position of x at time whatever? And if I said, well, the particle is here in 4 seconds, where was it at x equals 0? Well, at time equals 0. How do I do that? If I know where it is at 4 seconds, how do I find where it was at 0 seconds? Okay.
Sorry, would you like subtract the integral from 0 to 4?
Of how x changed over time. That's how you take the step backwards. Okay. Polar stuff. Tricky business is radius is in terms of theta. X is r cosine theta. Y is r sine theta. And be able to do the derivative. And then area of polars is 1/2 radius squared integrated over the angles. And I'd like to do some of those. So Alex, how do we start number 1?
Set up the y and x equation, take the derivative, but
Okay, so what is the what are those equations?
x negative cosine theta plus cosine theta sine theta.
Okay, so you distributed, I think I'm gonna leave them like this and just do product rule, but that's not wrong. So x is r cosine theta and y is what?
Negative, well, I guess sine times -1 plus sine theta.
So radius times cosine is x, radius times sine is the y. And totally fine if you want to distribute them out. Derivative of y with respect to theta. First times the derivative of the second plus second times the derivative of the first. Now, derivative of x with respect to theta. First times the derivative of the second plus second times the derivative of the first. And I only want to do one of these. But notation, like, this is dy d theta over dx d theta. This means evaluate all that mess at 0, don't clean anything up. Sine of 0, that first term goes away. Sine of 0, that also now goes away. Cosine of 0 is 1 times that -1. Down here, cosine of 0 is 1, sine of 0 is 0. So there's your slope evaluated at that. Lots of places to make mistakes, but nothing's especially hard. Okay with that? Question 3 was just being a pain, saying, find the derivative evaluated at these places. Clearly at pi over 2 and 3 pi over 2, the slope should end up being 0. And they can ask you that. They can say, hey, in this polar graph, where would the slope be 0? Find where dy d theta is 0. And dx d theta better not be 0 at the same place, because then it's an undefined. 13, they didn't give you a graph, but hopefully you can figure out how to graph it quickly. At 0, cosine is 1, so 4 plus 2 is 6. At pi over 2, cosine 0, so polars make round curves. At pi, cosine's -1, 4 minus 2, and then it's symmetric. So they're asking for the area inside that. 1/2 integral radius squared. Please show this tomorrow if I ask for this area. Get your parentheses right, because if the squared is not around on the parentheses, it's applied to be on either the angle or the trig function, depending on how you've written it. And that would be wrong. You need the whole radius thing squared. And I can integrate this from 0 to 2 pi or 0 to pi and double it, because there's a symmetry. Okay. The last one. A lot of questions about this one, and where do those circles intersect? pi over 4. So the purple circle, that's sine. At 0, it's 0. And then it intersects at pi over 4. This is asking you to integrate 0 to pi over 4, that guy squared, and that is this space. The other circle, the pink thing, the cosine curve, didn't really have anything to do with that. Then you had to think about it like, okay, now the rest of this shape, that was created by cosine. And it started at pi over 4 to pi over 2. And I got interrupted trying to bring up Desmos to show you guys this. But this is an example of the two curves intersecting and creating an enclosed area, but not over the same angles. In rectangular form, you guys are used to doing top minus bottom and integrate the area, or right minus left and integrate the area. Polars are not that way. I mean, they might be, and this is a case where they're not. I think I've completely confused you. Hi, Nick. Question?
Why is it only like that? A little slip for the sign? Right? Like,
Okay.
why is it big?
Let's see. So here's 2 sine theta. And I'm going to have it graph from 0 to pi over 2. 0 to pi over 4 is just that piece of the smiley face. Yeah? So if I want to find that area, does the cosine have anything to do with it? No. Okay. So I think in the homework question they gave you the picture? No? Oh, sorry. There's the cosine theta, and if I say 0 to pi over 4 for this one as well, it's the wrong space. It started at pi over 4 and finished at pi over 2. I won't ask you anything this tricky, and the AP can. I haven't seen them do it, but they can. So this is just a warning that they might require you to have some understanding of the functions and not be able to graph them, but understand where they pick up and where they stop. And in general, you get a calculator for these questions. You need to know how to use it and how to find those spaces, and be able to use the animate button where you can see it drawing out and see, okay, they didn't cross at the same time, or they did. Okay? All right. Did everyone get the polar AP question from last week? No. And the answer is on the back. Right over. Everyone else got one? Okay. So I have two other AP problems to hopefully do as practice today. Did everybody get one? No? Sorry.
But you got two, so actually, I
I did, and then I said, oh, never mind. Maybe you got one? Okay. And then I have two problems. I'm gonna give you 10 minutes for this. And that's not enough time to finish it, but I'll give you 10 minutes for this one and 10 minutes for the next one. Okay, let's look at what they have. So first thing, really read the question and read that top thing. You have a particle whose position is this, where x equals this equation and y is not explicitly given. But you do know how y is changing over time. So they give you the x position and the y portion of the velocity. So finding the speed, you need dx dt and dy dt. Be able to do the derivative of x, not so hard. Derivative of x. And please label your work. People are getting lazy on that. But then speed is that vector at 3. So plugging in 3. And speed of y at 3. Those guys squared under the square root. Added together under the square root. It did not say units, but sometimes they don't explicitly say that and they might take a point off. If they say indicate units, you will lose a point if you don't. Questions about that? And you can, on your calculator, do these values if you wanted to. Do you guys know how to get the calculator to do the derivative out of value? Like you say derivative and then evaluating at t equals 3? No?
Y prime is 3, just 2, right? 3 times e to the 0, which is 1, minus 1.
I was plugging in the 2. So, yeah. Because t is 3, not 2. I was looking at the number a bit directly above it. So, it is just 2, right?
Okay.
So it's root 8.
Yeah.
All right. Total distance. Now you needed how is x changing over time squared plus how is y changing over time squared, leaving those variables in there as time's changing over that 0 to 4 seconds. And typing it on the calculator might be the issue. So showing the setup, need to see all of this. 1 point for getting the integral, and because they know issues, being able to type it on the calculator correctly is 1 point. Part C. Sean, what did you say we'd have to do to find when the line of the tangent of the particle is horizontal?
Set to 0.
Set what to 0?
The derivative.
What derivative? I've got a couple.
Dx.
Okay, when it's horizontal is when dy dx is 0 and dx dt is not. And it's not this one that makes that point. Oh, they do make that point. When it's dy dt 0 and dx dt is not. If dx dt is also 0, then you've got some L'Hopital's conditions going on. Clearly, this is a calculator question. Are you guys okay with finding where that's 0? Yeah? No? And then that's saying the y stuff, we know what the change in y is, so it's asking how is it moving? Is it moving left or right at the time? Plug that time into dx dt. If it's positive, it's moving right. If it's negative, it's moving left. So it's not asking direction. It's not asking angle like pre-calc. It's saying, and it says specifically, is it moving left or is it moving right? So look at the change in x. And I don't think any of you had the time to get to part D. With its 3 parts, but part 1, they're not even showing you how they found it, but when does x of t equal 5? You didn't actually need a calculator, but you could use one. And that gives you the times, and then it's asking what are the slopes of the tangents? So dx, dy, dx at time 1. And then dy, dx at time 3. And the last piece, they're telling you the y-coordinate. Let's see, the whole story of this. They gave you the y-coordinate at 2, but they also said there's a point with the x-coordinate of 5. And the particle goes through that same exact coordinate, so the y values are the same. Y values are the same here. So to find y of 1 or y of 3, either way, it's y of 2 plus the integral 2 to 3, or y of 2 minus the integral from 1 to 2. You get choices. You should get the same thing. Okay. Take some thinking. And there's a couple minutes left. I gave you the third sample kind of question. Can you guys try that? And let's
Is it not?
I'm not supposed to get. What is this? All people sandwich?
I'm already cheating.
okay. Speed of a vector or is magnitude. So if that's my speed, So five speed times 3. Okay. What is the vector when it's times 3? I need to know how this is changing over time. That's the equation for x, so the derivative of that. And then they told me this one. And they wanted that speed at 3. Okay, stuff in 3. Three minus 1 is 2. So what is the length of that diagonal with 2 and 2 is, and you could leave it as square root of 8.
Because I got down to the 2 and 2, but I just didn't know what to do once I found something.
Find the length of the diagonal created by those.
Yeah.
So it's very confusing in the way we word this. Set time. There's things with the well, it's the same, I put 3, so it tells you x is 5, y is 7. But it will be the same calculation, so it should be the same
I actually do think I understand. So they're saying that if I add y2 down to the y coordinate, I know that y1 is x, y2 is the coordinate, right? So they're in the same. So then you're just saying that both of those are this coordinate plus whatever the change in the y coordinate here is.
The time
From that one, so from 2 to 3, whatever the change in the y coordinate is, will be add that to it. You have to do it. It says,
times where it hits that same x value, time 1 and time 3. So if I want to know what is the position of y of 3, it's wherever they told me was it y of 2 plus how much the y value changed over that 1 second. And if you wanted to do it the other way, y of 1 is the position of 2 and then minus. And the way they wrote the answer was like, what? Yeah, but, and these should come out to be the same. Okay, what is your
Well, I probably check with that.
and then plus 4 sine of negative 2. But even like that, there's no way is
The only thing you're allowed to ask is like where the data is.
trying to determine what
So, and it's asking for 0 to 5 or what?